gosh, I was asleep yesterday. Or last night, and still had dog.
Looks like a seashell.
A seashell.
Wait, what? Looks like the shell logo.
Oh, it looks like a football.
How does it?
Like a seashell.
How do you say a football?
How do you see it right here?
Okay. Okay, page 506 in your math book. I want to do like a page just as a little refresher for you, and then I'm going to set you up for the quiz. It's going to be a real easy quiz for you. And we'll be done for this week with math. And we can do our Pi lab tomorrow, Pi day tomorrow, and then Friday. Okay, so just as a reminder, right, we've been talking about powers and exponents. It's a shorthand way to write an expression, right? So in this example, 10 times 10, we use our base number, which is the 10, and our exponent is the 2, which is the number of times we multiply it by its times itself, right? Okay. So, and if it's 10 to the 2, we'll call it, bless you, squared, or 10 to the 3, we'll call it cubed. Okay, so on this page here, at the top, the zoo has an aquarium that holds around 7 to the 4th power gallons of water. About how many gallons of water does the aquarium hold? So if we expand this expression, right, this is the same thing. 7 times 7 times 7 times 7. So our base number is 7, our exponent is 4. And then when we multiply all those numbers together, we get 2,401. So you can see it's much more efficient to write 7 to the 4th power than it is to write all this out. Okay. So question F, Michigan has more than 10 to the 4th power inland lakes. Determine the value of 10 to 4, right? Well, we can expand that to 10 times 10 times 10 times 10, right? But another little shortcut, since you're using 10, we can just put the 1 there and then count how many zeros. So 1, 2, 3, 4. You go 1, 2, 3, 4. So that comes to 10,000. Okay. So that works with a base of 10. It doesn't always work when you're using a different number. Okay, so let's page 506, number 1 right here. I've got 8 times 8 times 8. What's my base number? My base number is 8, right? What's my exponent? It's 3. Okay, now I have 1 times 1 times 1. What's that? My base is 1. What's my exponent? 5. Very good. And then you can also use fractions and decimals. So if we go here, this is 1/7 cubed, which is the same thing as 1/7 times 1/7 times 1/7. And when you're multiplying fractions, you multiply the numerator then the denominator. So 1 times 1 times 1, which is 1. 7 times 7 is 49. 49 times 7 is 343. I just happen to know that number. Okay. Now I have a whole number 2 to the 5th. So that's the same thing as 2 times 2 times 2 times 2 times 2. Right? And if we just multiply that all out, that's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Right? So 2 to the 5th is equivalent to 32. Now we have a decimal. So 1.4 squared, right, is 1.4 times 1.4, right? And if I do the math, let me come up here, 1.4 times 1.4. 4 times 4 is 16, carry 1. 4 times 1 is 5. 4 times 1 is 4 plus 1 is 5. And then I have 4, and then 1, 6, 9, 1, and then, but I have to pay attention. I have 2 decimal points right here. 1, 2, so I have to move my decimal point over. So it's 1.96. Okay, coal mines have shafts that can be as much as 7 to the 3rd power or 7 cubed feet deep. About how many feet deep in the Earth's crust are these shafts? Right, so this is the same as 7 times 7 times 7. Right? Well, this looks real familiar to this up here. 7 times 7 is 49. 49 times 7 is 343 feet. Okay, building on the essential question, how can you generate equivalent expressions using exponents? Right, so really, powers and exponents is a shorthand. Have you heard that expression for shorthand? In the olden days, there's actually a separate language that people, when people dictate letters, they don't write the whole word out. They have abbreviated words and symbols, and then that secretary can go back and type that word up. So that's called shorthand. I don't even know if we use it anymore. We probably don't, because we have recorders now and we have text to speech. So we probably don't even use that anymore. But it was just a shortened, simplified way to take down words or take down text. And that's what exponents and powers are. It's a shorthand for you to write very big numbers. When you get into science and you're talking about the distance of the sun to the earth, you're talking a bunch of zeros. Well, it's much easier to write 10 to the 35th power than it is to write all those zeros. So it's a shorthand. The shorthand format using exponents. Okay, so example, if you had 9 times 9 times 9, right, that's 9 to the 3rd power, or 9 cubed. Okay, let's go over to the next page. We got page 507, right? 6 times 6. That's what? 6 to the what power? It's 6 to the 2nd power, or 6 squared. You can use the word squared. Now I have 1 times 1 times 1. That's 1 to the
3rd power.
right. Now I have 1. So now this is 5, right? 1, 2, 3, 4, 5, 6. 5 to the 6th power. And then this is 12 to the 2nd. And 1, 2, 27 to the
4th power.
Right? 15 to the
3rd power.
right. Okay. And I don't know what this number is. It's got to be a crazy number, right? But it's a whole lot easier to write 27 to the 4th power than it is to write out whatever that number comes out to be. Okay. Express each power as a product of the sum. Same factor, then determine the value. So now we're going the other direction. Now we're taking the base and the exponent and getting a result, right? So 6 to the 4th power is 6 times 6 times 6 times 6, right? And, right. So this, if you do all the math, which we'll just say, I'll just put it down to save some time, that is equal to 1,296. Okay, 0.5 cubed, or 0.5 to the 3rd power, is 0.5 times 0.5 times 0.5, right? So 5 times 5 is, that's 25, and 25 times 5 is 125, but now I have 3 decimal places, right? So if you have 125, 1, 2, 3, you go 1, 2, 3, so it would actually be 0.125, right? Okay, now you have a fraction, so you have 1/8 squared, or 1/8 to the 2nd power, right? And fractions, you multiply numerators across, denominators across. 1 times 1 is 1, 8 times 8 is 64. So it's 164. Okay? So just remember, you can use whole numbers, you can use decimals, you can use fractions, all with exponents. Okay, so let's go to, I think you got, by George, I think you got it. Okay, I'm going to set you up for the quiz. This is not very hard. Okay, number 19. Oh, let me pull it down. Number 19, Lily is studying the reproduction rate of fleas. She places 2 fleas in an enclosed habitat and records the number of eggs each day. She notices a pattern which is shown in the table. Predict the number of eggs in the habitat on the 5th day. Express the answer using exponents, then evaluate to determine the number of eggs. Okay, so we want to go to the 5th day. So let's look at our pattern. The first day we have 5 times 5. Second day we have 3 5s. The third day we have 4. The fourth day we have 5. So following this pattern, we would have 6. 1, 2, 3, 4, 5, 6. Okay. So you need to write this as an exponent and find your answer over here. Okay. That's 19. 20. Elena has a fish tank that holds 2 to the 5th power gallons of water. How many fluid ounces of water does the fish tank hold? So if you notice, we're talking gallons. We're starting with gallons here, but they want the answer in fluid ounces. So we're going to have to convert that measurement. But let's figure out how many gallons we have first. So this is 2 to the 5th is the same as 2 times 2 times 2 times 2 times 2, right? We got 1, 2, 3, 4, 5. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So we know we have 32 gallons of water in the fish tank. Okay. Now, the conversion rate is there's 128 ounces in 1 gallon. So for you to find the number of ounces in her fish tank, you're going to have to take 128 times 32. And that's your answer. Okay? Okay, that's 20. 21. Faith is turning 12 this year. She asked her parents to give her $1 on her birthday and to double the amount on her next birthday. If she continues with this pattern, how much money would Faith get on her 20th birthday? So let's just continue our chart, right? So this is 16, 17, 18, 19, 20. Okay, and if you notice our pattern, 2 to the 0, and just to let you know, any number with an exponent of 0 is equal to 1. Okay, so if you're out there and you see 5 to the 0 power, that's just the number 1. Okay, okay, but now her 13th birthday, 2 to the 1st power, 14th 2 to the 2nd power, or squared, 15th 2 to the cubed, or the 3rd power. So this is going to be 2 to the 4th. 17th is going to be 2 to the 5th power. 18th is 2 to the 6th. 19 is 2 to the 7th power. And 20 is 2 to the 8th power. Okay? So now we know that this is how much money she's going to make on her 20th birthday. So now we have 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. So all you have to figure out is what that value is. What's this? Okay, that's your answer for $21. Okay, 22. In a cube, in any cube, the length, width, and height each have the same measurement. Right? So here's a cube. Same thing as a square. The sides are equal in a square. A cube is just a 3D dimension of that. Right? The volume of the cube below can be found by calculating a to the power of 3, or a cubed. Now you know where they get the word cube now? When you have 3? Okay. So where a is the length of a side, suppose is 8 inches. So what we're saying is this side is 8 inches, this side is 8 inches, and this side is 8 inches. Okay? And actually, since it's a cube, it's a 3D, it's actually length times width times height. That's how you're getting the space inside the cube, right? You're getting the length, the width, and then the depth. Okay. How many gallons of water would the cube hold if 231 inches is equal to 1 gallon? Round the answer to the nearest tenth. Okay. List the steps you use to find your answer. Okay. So the first thing we have to do is find the volume inside the cube. So we're going to find the volume. Right? Which is, volume is going to equal to 8 to the 3rd power. Okay, number 2, we're going to divide the volume, I'm just going to put V, by 231, because we know that 231 cubic inches is equal to a gallon of water. Okay, and then we have to round it to the 10th place. Okay, so volume is equal to 8 to the 3rd power. So volume is equal to 8 times 8 times 8. Okay, and when you multiply that, you actually get 512 inches cubed. Okay, but now we have to take this, and yes? Yeah, sure. So volume is equal to 8 times 8 times 8, which that number comes to 512 inches cubed. But now we have to divide 512 by 231 to find out how many gallons we have. So now we're going to take 512 divided by 231 to get gallons. Okay, so you're going to put 512 in the doghouse, divide by 231. Don't forget your decimal points right here. And this is your 10th place. Okay, so all you have to do is do your division problem, 231 into 512, and you'll get your answer. Okay, not too bad, right? Okay. So we have basically 23 minutes left. So I'm going to let you finish this. Do your Google quiz. So you're done. We're done with math. If you finish that, then finish your packet. So you're all done with math. And then tomorrow we'll be ready to do the Pi Day. And we're all done before Friday. Okay, so go ahead and finish this, put this in your Google quiz, finish that up, check your packet. If you have anything done left in your packet, if you're done with your packet, you can bring it to me, I'll mark you off. Okay.